Alright, so before we screw around with Massive, I figure I should give a TLDR version of the process of subtractive synthesis, so I'll try to do that without dwelling too much on the tedious BS of acoustic theory. One sentence. You think I could do it in one sentence? Okay, I'll try that. Sound is made up of waves. Waves are made up of harmonics. Sine waves only have one harmonic. Triangles have a few more. Squares are louder. Triangles. Saws have the most harmonics. And subtractive synthesis works by subtracting certain harmonics with filters. Alright, cool. That was a fairly decent nutshell, I think. Skipped over envelopes and LFOs, but we'll get to those later. Okay, so most subtractive synths have at least a sawtooth and a square wave, possibly a triangle as well. Now, the audio from that is routed into the filter. I think it's pretty safe to assume that all subtractive synths have a low-pass filter, and many of them also have high-pass and band-pass, and there's a handful with notch or band reject filters. Then, the filtered audio is routed into the volume envelope, and that's your sound. Now, that's just this... Hang on, let me get a water. There we go. Now, that's just the skeleton of the most basic of subtractive synthesizers, but hopefully it's enough to give an idea of what's going on here. And because it's so basic, it's just enough to show you how to make one of the most basic synthesizer sounds, the 303 bass. And it's stuff like this that makes me wish I had an external camera. Well, I suppose it doesn't really matter. I mean, the rest of the videos are probably going to be done with soft synths. Anyway, I need more water. Okay. So the original 303 had both sawtooth and square waveforms, so we'll be using a sawtooth for now. The 303 was monophonic and had only a single oscillator, which was routed into a low-pass filter, which was either 18 or 24 decibels per octave, depending on who you believe. People are still having shitstorms over that. The microbrute is also a monophonic synthesizer, albeit more expansive in its timbral palette. So here we have one sawtooth oscillator, but it doesn't sound much like a 303. This is an important thing to note, as it shows just how important filters are in subtractive synthesis. The sound of the 303 was produced by the cutoff of the filter closing as a note was played, like this. But if you can find somebody who can play squelchy 303 lines while turning this knob repeatedly to the left with every note, I'm going to pay them a lot of money, because they'd have to be incredibly talented to do something that a human being can't physically do. That's where the envelope comes in. The microbrute only has one envelope, but it can be routed to the amplifier, the filter, pretty much any parameter you can think of, and that should be all we need for this sound. I'm going to set the amplitude envelope to gate, meaning no attack, no decay, no release, just a simple on-off pulse, like that. And then by turning this dial, envelope amount, well, it's already, there we go, it was already there. By turning that there, I'm going to use the envelope to control the cutoff. Oh, wait, I know what's wrong. Here I go, deviating from the script now. I have this set to sustain, which is basically the same as gate. Sustain just means it stays at, since this is at the top, the highest value. So the filter sounds completely open. We can change that, though. There we go. So an ADSR envelope, an ADSR envelope can be visualized by this graph. The highest point is the maximum, the lowest is the minimum, and this axis is time. Basically, once a key is hit, these are the values that go to the parameter that the envelope is controlling, in this case, the filter. The highest point is where the filter will let the most harmonics through, and since it's a low-pass filter, in this case it'll be a brighter sound compared to the lower points, which would be more muffled. The shape of the envelope of a 303 sound looks like this. I can't. I only have so many fingers. The attack is so quick it's inaudible. The decay is short, and the sustain and release are both at the 0 point. This is kind of sound like math homework. So, well, the more you play around with it, with envelopes, the better you'll understand them. You can dial in how much you want the envelope to affect the cutoff. And then if you want a more squelchy, acidic sound, that's when you turn up the resonance. The resonance control, it's also been labeled as Q for some reason on some synthesizers, don't ask me. It alters the... Hang on. What? Alright, the resonance control alters the shape of the filter so that the frequencies at the cutoff point will be louder or more emphasized, bringing out more overtones to the sound. Yeah, you know that sound already, right? Add some a little glide, a little portamento to... That's really all there is to it. If you got any questions before I make the massive video, just tell me, alright?